Thank you. I'll try to make this as quick as possible. Brill have been good enough to offer me 2 opportunities to speak, so I'm actually going to give a talk here and another talk at the opening. This is the more technical of the talks, and it's about how the Brill fonts were built. And then the second talk, a shorter one, will be about how they were designed. I realized, as I was working on the slide, this project has been part of my life for 5 years now, and part of Pim Rietbroek's life for longer than that. So there are many ways I could come into a discussion of the Brill project. So this talk represents only one possible route in, but it was one that made a certain amount of sense to me as I was working on the slides. And how do you do that on a Mac? Thank you. Spot the Windows user. So I have 2 definitions I want to throw out just quickly at the beginning. I know, some of you are typographers, type students, etc., so this won't be any surprise to you, but it's helpful to think of 2 terms, character and glyph. Glyphs have been mentioned already, but a glyph is a font unit, and a character is a text unit. At this point in time, when we're dealing with metal type, there's no distinction between the 2. So when people talk about metal type, they tend to talk about characters. And by character, they mean a lump of metal with something on it. That ceases to be useful when we're talking about digital type, because we're also talking about digital text. So if you look in the middle of this screen here, there's this FF ligature. So it's 2-letter F that are joined together for reasons of design. But the fact that these are 2-letter Fs exists only in the mind of the typesetter. The lump of metal has no intelligence. Only the person setting the type has intelligence. That all completely changes when we're dealing with digital type, because we're dealing with digital text, and these days mostly Unicode encoded. So the character is a piece of information that is stored in the computer that says this is a character F and this is another character F. And the information that has to tell the typesetting process how to display this then must be contained within the font. And so preferably contained in the font. I mean, when digital type first came along, if you wanted to typeset well, you played a lot of messy games. These days, thanks to OpenType and other technologies, a user can simply type along. They type the sequence FF, and a well-made font is going to display it with an FF ligature glyph, one possibility. But the fact is, when you encounter this printed on a page or displayed on the screen, you have no idea how this is displayed. Yo talked about this phenomenon already when looking at printed metal type. You can't always tell how it was structured. You actually have to go back and look at the metal in order to understand the processes that allowed this to be displayed. So I want to introduce this other term now, typeform. A typeform is an agnostic visual unit of displayed text. And it's agnostic because you don't know how it got that way. Here's another typeform. Now this is the Brill Typeface. This is a diacritic that is this potentially does exist in the transcriptions of some African languages. So this is the bar on the letter I indicates that this is a fronted vowel. The cedilla underneath indicates that it's nasalized, and the circumflex above indicates that it is spoken with a rising falling tone. So this is something that could actually occur in the sort of publications that Brill deals with. So, dealing with transcriptions of languages, dealing with linguistics, these sorts of topics. You look at this, you have no idea how it was displayed. There are a number of options. So this could be a precomposed glyph on the far left. This is a single unit in the font. Or it could be 2 units. It could be a barred I with a circumflex above that's had a cedilla applied to it, or vice versa, a barred I with a cedilla that's had a circumflex attached to it. Or it could be a barred I that's had a cedilla and a circumflex attached to it, and then you could even decompose the bar itself, and so you can see there's anywhere from 1 to 4 glyphs could have been used reasonably to display this particular type form. And then there's the question of how is the text encoded? Unicode, for various historical reasons involving round-tripping with pre-existing character sets, contains a certain amount of messiness. Ideally, there would be one way to encode any particular text entity. But in actual fact, there are multiple ways this particular type form could have been encoded. So not only do you not know from looking at it how it's been displayed, you don't know how it was encoded. This could be an I with a combining bar, with a combining cedilla, with a combining circumflex, and those could have been arranged in pretty much any order. And you sort of assume that the I part is going to come first and the others are going to be applied to it. But beyond that, the order is unknown. And of course, you don't know, how it was originally input. So you've got a situation where you have a type form that's probably from 1 to 4 glyphs, is either 3 or 4 characters, but in an unknown order, and probably 1 to 4 keystrokes by whoever typed it into their system, because thanks to modern keyboards, a single key may enter more than 1 character, or you can even have single characters entered by more than 1 keystroke. So really, you're dealing with attempting to arrive at the proper process, at the proper result of typesetting, which is the correct type forms looking correct in the correct places, and all of these variables that go into the possibilities of how they might have got that way. All of which is a very roundabout way of saying that the process of deciding how to go about building a font is the process of deciding what is the best way to arrive at the type form given the variables that are in play in the text encoding and the font technology and also the applications that are going to be used in the typesetting. The Brill project, because it's particularly large, the glyph set of each of the 4 fonts is now over 5,000 glyphs, supporting a huge number of characters, incredible number of languages, and in many ways a kind of open-ended need of Brill's typesetting. We have to think from the beginning very carefully about what is going to be the most intelligent way to build these fonts. Thankfully, a lot of the groundwork had already been done for me by Pim and some of his colleagues. They had prepared this document of what they called entities. Now, what they called entities is what I would call type forms. What they had done is they had gone and they had looked at all of their publications, going back a very long way, and had documented the things that they found in them. So the visual text units that they found. So that what they call entities, I call type forms. And they catalogued them. They had figured out what Unicode character or characters would be necessary to encode these. And it compiled quite a lot of information, including where to find them within Brill's publications. So, for example, certain things coming from the Encyclopedia of Islam project, for example. So this was delivered to me, and it was a great way to start the project. And one of the first things I decided was, this is not the approach from a font perspective. That if we simply made a glyph for each of these entities, we'd be at it for a very, very long time. And we would then only have produced what was necessary to typeset what Brill had already typeset. We needed to look at a process that would be open-ended and productive, so that anything that Brill threw at the font in the character sets that was to be supported would be correctly displayed. So, and this just gives you an example of some of the kinds of stuff that they were documenting in this. So, based on my analysis of their spreadsheet, I came up with a set of principles for how to go about building the Brill fonts. First was include only encoded diacritics of precomposed glyphs and use OpenType glyph positioning, dynamic mark positioning for all of the others. So only if a diacritic is in Unicode as a precomposed unit would we create a glyph for it, and there are simply technical reasons for wanting to do that. So what this means then, looking at that excerpt from the entities list, is that the 3 in black are in Unicode as single precomposed characters, and so we provide precomposed glyphs for them. The red ones, we filter them out of the spreadsheet, and those will be handled and displayed using dynamic mark positioning. And this is how that works for the kind of technically inclined among you, this is Microsoft's Vault tool for developing OpenType layout tables. And so what we have here is a list of bases and classes of marks, and we're defining an anchor saying, when this class of mark occurs after this base, this is where it is positioned. The second principle was to contextually decompose all those precomposed diacritics when they're followed by additional combining marks, with the exception that if the diacritic involves overlay elements, so bars across letters, things that kind of become part of the letter rather than simply a mark above or below or something like that, because there were design considerations to take into account where overlapping tended, sometimes to produce dark marks on the page, and I wanted to have control over the kind of the finessing of those outlines. Now, the reason for doing this, of course, is that instead then of having to provide that OpenType mark positioning information for every single precomposed diacritic glyph in the font, by decomposing them contextually at that stage, I could then apply mark-to-mark positioning. And that's what's happening here. So what we have is the A with diaeresis, a combining tilde has been added to it, and then we decompose it to the A combining diaeresis, combining tilde, and display them correctly using this mark-to-mark positioning. So as I did mark-to-base anchoring, I'm now doing mark-to-mark, which is somewhat more complicated because here this is defining the height adjustment. This is above, but you notice that the second glyph also has its own value. So I have to adjust the second glyph to ensure that there's a consistent visual distance between the two sets of marks. So now I've explained the first two principles, you should be able to figure out which of these 7 possibilities of displaying this type form is the one that I used. Any guesses? It's actually the one in the middle, right? So the first principle is that we only have the precomposed that are in Unicode. It just happens that the I bar is in Unicode. We don't decompose it because it involves an overlay, but we do then apply the 2 marks separately. Third principle, support of legation rather than ligatures. This is similar to Tom's approach to Arabic, and I've certainly been inspired by that over the years. A ligature as a thing, my definition slightly different from Tom's. Mine's a purely technical definition. It's a glyph that represents more than one character. The problem with if you start going down that route of creating ligature glyphs is that you start boxing yourself into a corner, because especially in a font with a large character set like this, the number of ligatures you need to be able to cleanly display anything that might be thrown at the font starts multiplying very, very quickly. So rather than speaking of ligatures, I like to speak about legating. So I treat it as a verb. What happens is a contextual behavior when certain shapes come into adjacency with each other. And so we have an example here. User has typed in the letter sequence FFI. There are OpenType G sub rules that substitute specialized forms, in the middle section here, specialized forms of these letters, which, when adjacent to each other, form a type form that looks like a ligature. This can also be used for dealing not only with sort of traditional ligatures, but with some of the kind of odder situations that occur given the character set that Brill are working with these sort of strange things like the hooked G. What happens when that is against an I? Well, we can perform a ligature-like effect. And the nice thing about this is that it's productive. I didn't have to design any of these ligatures. They just happen as a result of the contextual variants that are in the font. I don't know if any of these particular combinations would actually occur. Maybe the red one in the middle might occur for African languages. And note that the one in the middle is a ligature that has then had a combining sedia applied to the barred I, but all handled with units that have been contextually substituted and positioned relative to each other. The fourth principle, so, you know, on the one hand, Brill wanted to be able to handle any text that was thrown at the font. But, you know, they are serious publishers. They've got a 330-year tradition of some very fine publishing. And so they wanted to be able to produce high-quality typography for the stuff that was being thrown at the font, not just to be able to display a glyph that would be readable. So talking with Pim at the beginning of the project, we decided that we would have true small caps for everything. So for each of the three main scripts that are supported in the font, which are Latin script, Greek, and Cyrillic, for the uppercase and lowercase letters, when you're in a program like InDesign and you apply small cap features to it, you will get a small cap of even the most obscure, esoteric character in the font. And then also various styles of numerals that you would expect, case-specific variants, etc. And so here's showing some of the small caps, just some of the small caps in the font. And as you can see, there are some, as you move down the screen, some very strange letter forms in there. So the Latins, these are all, except for the lines of Greek and Cyrillic at the top, the bottom three sets of lines, that's all the Latin script. You know, we think of the Latin script as kind of A to Z, but this is including letters for transcription using the International Phonetic Association alphabet, also some other phonetic transcription systems. It contains archaic letters from Old English, Old Gothic, Old Welsh, medieval manuscript transcription characters, a lot of very strange stuff. And I'll talk a little bit more about some of those during the second talk. And the final one, the principles, we discussed this at some length because it's, this is really the sort of nerdy technical issue that probably isn't of very much interest to people. We decided we would accommodate Acrobat glyph to character name parsing. So most of you, I'm sure, work with PDF documents on a regular basis, or at least receive them, read them online. There are several different ways in which PDF documents can be created. If you export them from in a program such as InDesign, if all goes according to plan, the Unicode character strings of your original text are written into the PDF. And the great benefit of that, of course, is it makes the PDF searchable, it makes it indexable. You can put a PDF on the web, Google will find it, they'll index it. People can do searches for it, searches within the PDF. That's great. One of the other ways in which PDFs can be created is they can be distilled from a print stream. And the classic example of this is someone is in Microsoft Word and they do print to PDF. That function doesn't have any way to write the Unicode character strings to the PDF because a print stream only contains the raw glyph. It contains the glyph IDs, an embedded font, and a mapping of those glyph IDs to glyph names in the font. And that's all the information that goes with the PDF. And so Adobe had this problem of, they wanted all PDFs to be searchable. So how to do this? And so they came up with this elaborate method of parsing the glyph names to get back to what the underlying character string was. It's sort of clever, and it kind of works if a font has been very carefully made. And so I described all this to Pim, and we discussed it and decided that, yes, this is the way we would make the font, because it was important. Because these fonts are being made available to scholars to use, and not just to be used within Brill, that people should be able to create PDF documents that will be searchable, even if they're generating from the print stream. The oddity that it requires in fonts is that having kind of tried to be as efficient as possible in not including too many pre-composed diacritics and all this sort of stuff to try to keep the glyph set down as much as possible, I had to add substantial numbers of identical duplicates with different names so that when these glyphs are written into PDFs from the print stream, they can be parsed back to the underlying characters. So for example, at the top we have a duplication. We have two identical small cap A letters. One maps to the uppercase and one maps to the lowercase. In the naming convention that Adobe has, anything to the left of the dot should be mappable to a Unicode character, and anything to the right is just an identifier. The Greek set in the Brill fonts became quite interesting because there's a convention when you typeset all cap Greek, so all uppercase letters, most of the accents are dropped. So when you do case conversions or when you do display as all caps, most of the accents disappear. It's a bit more complicated than that. Some contextually appear while others contextually disappear. But what it means is that we end up with all these different forms of epsilon, that's only some of them, and all of the other accented Greek letters that are mapping to these. But these are the all caps variants of epsilon cilia oxia, epsilon cilia varia. And so if one opens the font in a Glyph viewer, one sees this incredible array of seemingly pointless identical duplicates, but it's all just to support this one particular behavior of one particular piece of software from, admittedly, a very important software producer. So those were the 5 principles that govern the building of the Brill fonts. It struck me that that is a very dull place to end a presentation, Adobe name parsing. So I thought I'd end with something very clever. The overlines and the lowlines. So among the Unicode combining marks, there's a combining overline and a combining lowline. And the intention, as specified in the Unicode standard, is that when on adjacent bases, they will connect and form lines. Sounds simple. So immediately the problem is, so unlike other marks, you've got the issue, well, you can't have them at different heights for the uppercase and the lowercase, or for the X height and ascender things. Or you could, but then the contextual rules to try to get them to line up based on what particular word someone was typing. I've done that in another font, but it gets very complicated. And Brill decided, no, they were happy to have everything at a uniform height, regardless of what the text was. That simplified some things a little bit. What's actually happening here is you've got, for example, an uppercase O followed by a combining overline, lowercase v, combining overline. So these lines aren't being drawn by a program. These are part of the font. They're part of the text. Someone has decided, this. And these are used in transcription quite often. So you'll get them above 2 letters, sometimes 3 letters side by side, indicating that there's some kind of relationship between these 3 letters, either linguistic or perhaps in the original manuscript there might have been a ligature, and this is a way of transcribing that. So the tricky bit is to get this to look good. So you want an overline, but generally probably of 1 length, maybe multiple lengths, but you want so when you have a single occurrence of it, it sits in a nice way over the letter. But then when you have 2 of them, you need it to connect in the middle. And when you have 3 of them, you need it to connect over all 3, and you need it to kind of keep going. So this is a bit of clever open type chained contextual lookups that are looking at where the first character with an overline is and where the last one is and the ones in between, and doing substitutions for length to make sure that no matter how wide or how narrow, so I'm looking at the uppercase W and the lowercase l as the widest and narrowest, that these always look nice. And then the really clever bit is that depending upon the mark ordering, you can have marks within the lines or outside the lines, and they will remain tied to their particular base, but will also not interrupt the display of the overline and the lowline. This was one of the last things I did in the fonts just in the last few months, and it took a while to figure out, but I'm particularly pleased with it, and that struck me as a clever place to end the presentation. Thank you.